Hi everyone, welcome to my channel. On this channel, I'm going to make videos about AI and how to build applications using AI. So in this video, we are going to understand how OpenAI's chat completion API works. We are going to explore all the parameters like top peep, temperature, presence penalty, and how they affect your output. Before you get started, you'll need an API key. To create your key, go to platform.openai.com and create an account. Once you're logged into your account, click on dashboard, and inside dashboard there is an option for API keys. Click on create new secret key and name your key and click on create. We'll use this key when we make requests to the API. So once you have your key, you'll need to install two Python packages. One is OpenAI and second is python-env. So this OpenAI package is an SDK to interact with OpenAI's API, and this python-env package will help us to load our API key through a .env file. So once you have both of these installed, open any text editor or an IDE and create a file. So from here we'll load a .env file and we'll create a .env file, and inside this file we'll define our API key. So OpenAI recommends that your environment variable, the environment variable that should have your API key is called OpenAI API key. So just paste your key here. So this environment variable will be used by OpenAI to read your key. So now to load our environment variable through this .env file, we'll use our package called .env. From .env import load.env and we'll call this function. So this function will read this .env file and declare our environment variable through this .env file. Now once you have these environment variables set up, we can now use our OpenAI package. So this OpenAI package has an OpenAI class with a capital O and capital AI, and this class has all the functions to call the API. Now we'll create an instance of this class. So this instance will be used to create request and send request to the OpenAI API. Now let's talk about OpenAI's chat completion API. So before that, let's talk about what a chat is. A chat is basically a list of message, a ordered list of message and each message will have a role and a content. So role basically means who has sent a message and content is what the message actually is. Okay, so in a chat application we'll have a bunch of messages. Each message will have a role like who has sent the message and a content, right? Similarly, in the chat completion API we'll send a list of messages to the LLM. Okay, and each message will have a role meaning who has sent the message. In this case, the first message is a user message, meaning the user has said something to the LLM, and the content of the message is what the user has sent. Okay, and other parameters we are going to send with to the LLM is the model which we want to use. So OpenAI has a lot of models: GPT-4o, O1 mini, O1 preview, and other parameter is basically n. So we don't need to send this n message, it's not required. So what happens is the LLM will try to predict what the next message that the AI should send. Okay, so that's what a chat completion API does. It will predict the next message that the AI should send, right? So by default, it will predict one message. Okay, but if we increase the value of n to 2, then in that case, it will send us two predictions. Okay, so once we send this request to OpenAI's server, it will respond back in this kind of format. So in the response, we'll have a choices array. So in this request, we have set n to 2, right? So it will give us two predictions. So in the choices array, we'll have two messages, and each message will have a role of assistant, meaning what assistant is going to say in the conversation and the content of the message. Along with these two messages, we'll have some other parameters like usage. So in the usage, we'll know how many tokens we have used. So we'll talk about tokens next, but before that, let's code this. Now to code this request and response that we have just seen, we'll call this function called client.chat.completions. So this chat.completion means we are calling the chat completions API, and we'll call the create function. Okay, so this create function will create a request and send to OpenAI's server, and it will include our API key through the environment variable that we have set, and also the environment variable that we have set has the API key. Also, we can set our API key directly inside the constructor. So we can also do it like this. But environment variable, it's safe. You can put this environment variable in a .gitignore file, and it will not be pushed to GitHub or other repositories. So yeah, so once we have this client, once we call this function, we'll pass in the parameters that we have seen. So first the model, let's call the GPT-4o mini model, and we'll send a list of messages. Okay, and each message will have a role. So in this case, what user is saying, so user is saying, let's say, uh, content, hi. Okay, and this call will give us a response. So let's store this in a response variable, and we'll also set n to 2. That means we want two predictions. Okay, so as we have seen, the response will have a choices array. So what we can do, we can loop through the choices array for choice in response dot choices. So we can loop through the choices array, and inside the choice we'll have a message. So we can print the choice dot message dot role. So who has sent the message? In this case, it's going to be assistant, and the choice dot message dot content. So let's run this script. Yeah, so you can see the first message is assistant. Hello, how can I assist you today? Second is also the same. So in this case, the messages that the predictions that the AI has done is same. But let's say if we ask it, hi, how are you? Yeah, so in this case, you can see the predictions are different. So I'm just a computer program. Hey, hello, I'm just a computer program. So in this way, we can send requests to the chat completion API. Okay, so now let's talk about how LLMs actually work. Okay, so let's say a user sends a message, hi, how are you? Okay, so what OpenAI will do is it will convert this string into a list of tokens. Okay, so the tokens can be hi, comma, how. So OpenAI has a tokenizer which we can use to see these tokens. Okay, so this string is converted into 6 tokens, and we can see these tokens. Okay, so it will convert this string into tokens, and now it will feed it to LLM. Now what LLM is trained to do is it is trained to predict the next token. So given this list of tokens, it is trained to predict the next token. Okay, so LLM has list all the possible tokens, the list of all the possible tokens. So what it will do is it will assign probabilities to each of these tokens, all the possible tokens, and it will choose the token, one of the highest probability token. Okay, so not the highest probability. So in this case, hello has the highest probability and it chooses hello. Okay, but it's not always the case. It will always choose the highest probability token. It can also choose IM. Okay, so the reason it doesn't choose the highest probability token and it chooses one of the highest probability token is to add randomness to the response. So if it's always the highest probability token, there won't be any randomness. Okay, so randomly it will choose one of the highest probability token. Now we can also control this randomness using a parameter called temperature, which we'll see next. But this is how LLM works. Okay, it will assign probability to one of to all the tokens that are possible, and it will choose one of the highest probability token. Okay, and it will add this to the generated response. Now LLM will again keep on doing this recursively. Okay, so now again it will assign probabilities to all the tokens, and it will choose the highest probability token. Okay, one of the highest probability token, and it will keep on doing that, and in this way it will generate the response. Okay, now there is a way for us in the chat completions API to see these probabilities. Okay, so we can see these probabilities using a parameter which we can send in the request, and it's called logprobs. Okay, you can set it to true, and in the response along with the message, so in this case n is 1. Okay, so it will only get one message. Okay, so in along with the message we'll also get a logprobs key, and inside that key we'll get a content array, and inside the content array we'll have a list of tokens and their probabilities. Okay, so now let's code this and see the probabilities. All right, so let's remove this n is equals to 2. So in this case we'll only get one prediction. We'll set log props to true. All right, we don't need this, we don't need to loop through this choices array because we'll only get one choice. So inside response there will be a choices array, and we'll get the first choice because there is only one response that we are getting, one prediction we are getting. And inside this choice there will be a log probs key, and inside this key we'll have a content key, and inside this content key there will be an array. So we can loop through this array, and we'll loop through each objects in this array. So each object will have a token. We can print the token, and each object will have, along with the token, the probability of the token. So let's print this and see how it works. Yeah, so you can see the first token is hello, and we can see its probability. The second token is exclamation, and we can see its probability is 0, and the third token, and in this way we can see all the tokens, right? All right, now let's talk about a parameter called temperature. Okay, so how LLM works is they try to predict the next possible token, right? And the way it does this, it assigns probabilities to all the possible tokens, and it chooses one of the highest probability token, right? So how randomly it chooses that token can be controlled by this parameter temperature. Okay, so by default the value of temperature is 1, and its value can range from 0 to 2. Okay, so let's say the user asks LLM to write about technology, and we increase the temperature to 2. Okay, so in this case what LLM will do is it will predict the tokens more randomly. Okay, it will choose the highest probability token in a more random fashion. Okay, so you can see the response is technology mediates our modern worldview, and after that you can see the tokens are very random because the temperature we have set is very high. Now let's say we decrease the temperature to 1. Okay, so in this case the tokens that the LLM choose, it generates a decent response, and you can see the response has words like wheel, printing press, internet, artificial intelligence. So it talks about more diverse things. The tokens are more diverse. Okay, but if it decrease the temperature even more to 0, now you can see the response, it doesn't talk about wheels or printing press. The only tokens are internet, artificial intelligence. So it chooses the tokens with higher probabilities, right? So if we increase the temperature to 2, it will choose tokens with lower probabilities. But if we decrease the temperature to 0, then it will choose tokens with higher probabilities. So this is how temperature will work. Okay, it controls how randomly it selects the token, how randomly the LLM selects the token, and how random is your response. Okay, so now let's code this and how see how it works in code. All right, so let's remove this for loop and also this logprobs parameter, and let's set temperature to 2 in this case, and let's say write about technology. Okay, now let's print the response. So in the response we'll get a choices array, and we'll get the first choice, and we'll print the message content. All right, so let's run this. All right, so now you can see the response is very random. It includes characters from different languages, and it includes some random words. All right, so the reason for this is because we have set temperature to very high, so in this case the response is very random. All right, so now that we know how temperature works, so what we can do is, instead of just printing the probabilities of all of these tokens, the tokens that the LLM has generated, we can also print the probabilities of top n tokens. Okay, so the LLM, it predicts probabilities of all the tokens. Okay, so to predict the next token, all the tokens it is considering, and for all of these tokens it's predicting the probabilities, right? So we can also print the top n tokens. Okay, so what we can do is we can set a parameter called top log props, and we can set it to. Okay, so what it will do is, so it will give us the token and its probability, the token that it has generated and its probability, and along with that it will give us an array of two tokens, the top two tokens whose probabilities are the highest. Okay, so in this case the token hello and I am has the highest probability, so it gives us the top two tokens. We can also set it to 5, so in that case it will give us the top 5 tokens. Okay, so the top 5 tokens would be hello, I am, hi, I, hey. So in this way we can print the probabilities of top n tokens. So let's code this and see how it works. All right, so let's remove this print statement. Let's remove the temperature also. Let's change the prompt to hi, how are you? Let's set the log probs parameter to true to return all the probabilities. Let's set the top log probs to 5. So we want to, for each token that the LLM is generating, we want the top 5 tokens, the top tokens, the top 5 tokens with the highest probabilities. Okay, so in the response, we'll have a choices array. Okay, since n value is 1 here, we'll only get one choice. We'll pick the first choice, and inside this we'll have a log probs key. Inside that we'll have a content array. So inside the content array we'll have objects. So let's loop through each object in this content array. So let's print the token that the LLM is generating. Let's also print the probability of this token. Okay, so this we have already done. Okay, we have already printed the tokens that the LLM is generating and its probability. Now let's print the top 5 tokens. Okay, so whenever LLM is trying to predict the next token, let's print the top 5 tokens and their probabilities. Okay, so uh, we'll add a tab space to print more clearly top log props. And so inside this log prob object, we'll have a top log probs array. Okay, we'll loop through it for top log prob inside this array. So we'll loop through it and we'll print the top token and its probability. Okay, so now let's run this and see. All right, so now we can see all the tokens that the LLM is generating. So in this case, the LLM is generating IM, and we can also see the top 5 tokens, the top 5 tokens with the highest probabilities. So you can see the top token is hello and its probability is minus 0.23, and the second token is IM and its probability is minus 1.73. So you can see the LLM, it's not always the case that the LLM will only select the highest probability token. It can choose one of the highest probability tokens. Okay, so this is how it works. The highest probability token is hello, but in this case it's choosing IM, and how randomly it selects these tokens can be controlled by this temperature variable. All right, so now that we know about tokens, probabilities, temperature, and all of these things, let's consider another parameter that we can use with the chat completion API. So this parameter is called top P, and its value ranges from 1 to 0, and by default the value is 1. So what happens is, in LLM, when it tries to predict the next token, it calculates probabilities of all the tokens and it considers all of them, all of the tokens, and it chooses one of the highest probability token. So it considers all of the tokens when it's choosing a single token, right? So what we can do is we can change this behavior using the top P parameter. Okay, so by default the value of top P is 1. That means 100%. It's considering 100% of the top tokens. That means all the tokens, all the probabilities it's generating for all the tokens, it's considering all of these tokens and choosing one of those tokens. Okay, but if we decrease top P to, let's say, 0.5, then in that case it will only consider the top 50% of the token. So the top 50% of the tokens which have the highest probability will be considered. And if we decrease it even more to 0, then it will only consider the top token. Okay, the top probability token. Okay, so this is how it works. So let's say the top P is 0.2, then it will take all the probabilities of all the tokens, and it will take the tokens with the probabilities that are at the top 20%. Okay, so this is how top P works. So let's say the top P is 1, and if a user asks write about technology, then in that case the assistant, it generates a response, and if you can see all the tokens that are generated, so in this case the tokens that are generated, it has some diverse words like human capabilities, modern life, communication, business. So it's talking about all of these things. So the all the tokens are considered. That's why we have all of these diverse words in the response. If we decrease that top P to 0.5, then in that case you can see there are less diverse words. There are words like scientific knowledge, human life, communication. And if we decrease it even more to 0, then you can see there is only one diverse word I can see in the response. Okay, so this is how the top P parameter works. So let's code this. All right, so let's remove this for loop, and let's remove these two parameters, and let's add top P is equals to, let's say, 0. And if we print the response choices, we'll pick the 0th choice and message dot content. Let's run this. Yeah, so you can see the response, and you can check the response. Like, it's really there are not many words that are being used in the response. So you can read this and you can find out what the difference is. So basically I've told you the difference, and you can try out different top P parameters and see how it works. Now let's learn about messages. Okay, so we have already talked about messages array. It's a list of messages that are there in the conversation, and the LLM tries to predict the next message, or what the AI should say in the next message. Okay, so that's what chat completion API does. So in the messages array, there are 3 kinds of messages, or 3 roles of messages. Okay, so the first role is system. So what does system mean? So let's say I'm building an application. Now and I'm using OpenAI. Okay, it's chat based application, and so I can instruct the app, the application that I'm building can instruct the LLM to change its behavior. Okay, so basically I can tell the application to respond in a certain way. So let's say I'm building a content writer based chatbot. I can instruct the LLM that you are a content writer, so respond in this way. Okay, if a user tries to ask you information about some random topic, for example, if it tries to ask you to solve some maths problem, just don't respond, just say I'm a content writer. Okay, so all of this information we can send in this system prompt or a system message. Okay, so this is what system message is for. So in this case I have added a system message, and in this system message says you are alpha. So basically I'm instructing the AI that your name is alpha. So if from here on, if someone asks you your name, just respond you are alpha. Now one more thing, the system message generally it's not shown to the user. So if you are building a chat based application, you don't show system messages to the user. You don't want user to know that you're instructing the LLM in between, you're saying you're interfering in between, you're saying to the LLM to respond in a certain way. So you don't want that. So generally all the chat applications that you have used online, all the AI application, you don't see the system message, right? Next, let's say a user comes and user says hi. Okay, so what we'll do is we'll send this messages array to the OpenAI server, and it will respond with a system message, with an assistant message, sorry, with saying, hello, how can I assist you today? All right. So one more thing, the OpenAI's API doesn't store any of these messages for you. Okay, it's our job as application developers to store these messages. Okay, to store these messages, and if a user tries to revisit this conversation, they can see all of these messages. Okay, so it's our job to handle this messages array. All right, so we send this messages array to the server, and it returns an assistant message. Okay, now let's say a user wants to continue this conversation, but the thing is OpenAI doesn't know what happened in the last conversation, right? So what we'll need to do is we'll need to include this assistant message with this messages array. Okay, so what we'll do is we'll modify this messages array and we'll include this assistant message. So this is how the messages array will look like. Okay, we'll add this assistant message. We'll say, okay, last time you responded with hello, how can I assist you today? Next, what we'll do is, next if a user comes and says, let's say what is your name, we'll also add that user message to the array. Okay, now we'll send this entire messages array again to the OpenAI, and the reason for doing that is because OpenAI doesn't know what happened in the last conversation. It doesn't store any of the messages. That's why we need to send all of these messages again. All right, so now if we send all of these messages again, the prediction that the AI will make is it will send us an assistant message saying, my name is Alpha, how can I help you today? So here we learn two things. One is system message. So system message we can use so in the application can use system message to instruct the LLM to behave in a certain way, or to respond with certain queries in a certain way. All right, and other thing is OpenAI doesn't store any of the messages. So if you are making a chat application, you need to implement this kind of a behavior. Okay, if assistant replies back, you need to handle this messages array. Okay, so this is how it works. We send this messages array and it returns back with my name is Alpha, how can I assist you? Okay, so now let's code this. All right, so let's remove this print statement and this top p parameter, and instead of defining this messages array here, we'll define a variable and store it in this variable. All right, and we'll pass this variable here. Okay, so we'll edit this array and we'll add a system message saying that the content you are alpha. All right, and let's change the user message to hi, and let's add a comma here. All right, so now let's print the response from this. So we'll take the first choice and we'll print its role, and then we'll print its content. Okay, all right. So once we get the first message from the LLM, we'll store this message again in this messages array. So right, that's what we did in the example. So we'll take the messages array, we'll append another message here. Role is going to be the role that we get from the API, and the content is going to be again what we get from the API. All right. So now that we have the assistant message in the messages array, we'll add what the user is going to say next. Okay. So let's say the user will append a message. Let's say the user is going to say, what is your name? All right. Now what we'll do is we'll again call the API. So we'll again call this function and we'll pass the model and we'll pass this new messages array. Okay, so earlier what we had was these two messages. Then when we send the request to the LLM, we'll get a response back. We append that response to the messages array. Then we append the user's message. So the next the user is going to ask what is your name, and again we call the API, but this time with the updated messages array. All right, and now we'll print again this response. Okay, so now let's run this. All right. So as you can see, the first response is, hello, how can I assist you today? Second response is, I'm called Alpha, how can I help you today? All right. So you can see the LLM has memory, or it has knowledge of what messages we have sent earlier. Okay. So earlier system has sent that said that you are Alpha. That's why the assistant is responding that I am called Alpha. All right. So this is how typical chat application with AI works. Next, let's talk about another parameter that we can send in the chat completion API. It's called presence penalty. Okay, by default, its value is 0, and its value can range from -2 to +2. Okay, so this parameter controls how often the LLM can repeat words. Okay, so if we decrease presence penalty, let's say to -2, then the AI can repeat words. Okay, so if for example I ask it give 100 words, okay, and the presence penalty is -2, then you can see in the response the innovation is repeated 5 times. Okay, and industries is repeated twice, and technology is repeated twice. Okay, revolutionizing possibilities, all these words are repeated again and again. Okay, so this decreases the penalty that is charged on the LLM when it generates content. Okay, now by default the value is 0. So in this case you can see there are 3 repeated words, village, and in this case joyfully is repeated twice. And if we increase presence penalty to, let's say, 2, then you can see there is very little repetition. Okay, so you can see wind is repeated just twice. Okay, so this parameter controls how often a word is repeated. Okay, how much LLM is penalized to repeat a word. Okay, so let's now code this. Let's remove all of this code and let's remove this messages array, and we'll define it here. We'll send a message of role user, and content is give 100 words. Okay, and we'll set the presence penalty here to -2, and let's print the response, and let's run this. Okay, so we'll copy this text and put this in a word frequency counter. Okay, and here you'll see that some of the words like new is repeated twice, each is repeated twice, day is repeated twice. Okay, and some similar words might also be repeated twice here. And this seeing, you see moments is repeated twice. Yeah, yeah, so you can you can change this parameter, change the presence penalty to see how it responds to different prompts, and you can play around with this. Okay, so the next parameter we are going to look at is called stop. So this is an array of strings. Okay, so what will happen is let's say if I ask LLM to write about technology, right? So the LLM will start generating text, and the first word, most probably the first word that it will generate is something related to technology, right? And if this word is in the stop array, the LLM will stop generating and it will give us an empty response. Okay, to take one more example, if we have a stop array with a word at, okay, so the LLM will start generating. So you can see it generates some text. Technology is one of the most dynamic and rapidly evolving fields, and after generating some words, we encounter a word called communication. Okay, now in communication we have the word at, right? So from at, it will stop generating. Okay, so this is how the stop parameter works. Okay, to code this, let's remove this presence penalty and let's change the prompt to write about technology, and let's add a stop parameter and let's add the word at in this. Okay, let's run this. Okay, so you can see we get this generated text. Technology refers to application. Okay, so it was trying to write something related to application or applicant or something like that, and it stopped generating because at was in that. Okay, so this is how the stop parameter works. One more thing I wanted to talk about was this usage object. Okay, so when we get a response back from the OpenAI server, we get this usage object which has prompt tokens, completion tokens, and total tokens. So this prompt token represents what is the number of tokens that we have sent in the messages array. Okay, and completion token is what is the number of tokens that the AI has generated. Okay, so it will be the sum of all of these messages, the number of tokens in all of these messages. Okay, and total tokens will be the sum of both of these. Okay, and the reason I'm showing this is because for each of the models that OpenAI has, each of the models has a context window and a max output tokens. Okay, so context window represents what is the maximum number of total input tokens and output tokens that this model can handle. Okay, so let's say we have n number of input tokens that we are sending to the server, and the server generated m number of tokens. So the context that the LLM currently has is n plus m. Okay, and if this number increases, let's say 128,000, then the API will give us an error. It will say that the context window has exceeded. Okay, so if you are sending tokens to the LLM, just make sure that the context does not exceed 128,000. Other thing that this LLM has is max output token. Okay, so in this case it's 16,000. So what does that mean? That means that the maximum number of tokens that this LLM can generate in one API call is 16,000. Okay, it won't be able to generate more than that. Okay, so a parameter which is related to this is called max completion token. So we can set this parameter to define what is the maximum number of tokens that we want. Okay, so the LLM won't increase this limit. Okay, so if in case we set maximum completion token to 1, you can see we only get 1 token. Okay, so if we try to code this max completion parameter, you'll see we'll get an error. Okay, and I think there's a bug in the Python SDK for this. Let's run this. So you can see this max completion error. It says this is an unexpected keyword argument, so it doesn't support this for some reason. But if we try to do the same thing with the API directly, so all of the things that we have done in this video can also be done with the API. Okay, so we can send a post request to this endpoint with our request object, and we'll also need to send our API key. So our API key should be sent as a bearer token in the headers with the API key here. So you can set your API key here, and we'll send this body with our messages array, and we'll set max completion token to 1. Okay, so if I send this, you see it works fine. We'll get a response. Okay, and you can see in the choices array we get a message with a content with just 1 token. So this is how it works. There might be some bug in the Python SDK. If you can go to GitHub and can raise an issue, and maybe you can contribute on this and fix this issue if you are interested in that. And that's it for the chat completion API. If you like the video, please give it a thumbs up and subscribe to the channel. In the next video, I'm going to talk more about the OpenAI's API, and that's it. Thanks for watching.